Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today. For exam P on probability. Company XYZ provides a warranty on the product that it produces. Each year, the number of warranty claims follows a Poisson distribution with mean C. The probability that no warranty claims are received in any given year is 0.60. Company XYZ purchases an insurance policy that will reduce its overall warranty claims payment costs. The insurance policy will pay nothing for the first warranty claim received and $5,000 for each claim thereafter until the end of the year. Calculate the expected amount of annual insurance policy payments to company XYZ. And here's the solution. Let us write n for the number of warranty claims received by company XYZ. Then we know from the problem that the probability that n is 0 is 0.6. But because n follows a Poisson distribution with mean c, that has to be equal to e to the minus c, so that c must be equal to negative, or minus actually, natural logarithm of 0.6, because natural logarithm of 0.6 is negative, and the minus makes this number positive, and this number is approximately equal to 0.5108256. And we're looking for the expected amount of annual insurance policy payments to company XYZ. Well, that's equal to 5,000 times, 5,000 is a payment amount for each claim, but the payments are made only for the number of claims exceeding 1. So when there are 2 claims, there's 1 payment. So we multiply by probability that n is 2. When there are 3 claims, 2 payments are made, so plus 2 times probability that n is 3. When there are 4, 3 payments are made, so plus 3 times probability that n is 4, and so on. Now we rewrite this in such a way that we put 5,000 times and 0 times probability that n is 0. Of course, this number is 0, so it's not really relevant for calculation, but it's there for a purpose. Plus 1 times probability that n is 1, plus 2 times probability that n is 2, plus 3 times probability that n is 3, and so on. And as you can see, this whole large sum in parentheses here is simply the expected value of n. But to get that, we need to make some adjustments for this to be equal to the initial expression that we had there. So, of course, the 0 times probability that n is 0 makes no difference, but we didn't have 1 times probability that n is 1, so we need to subtract it, and of course it's multiplied by 5,000, so we subtract 5,000 times probability that n is 1. And we had only 1 probability that n is 2, now we have 2, so we need to also subtract that. Of course, in parentheses it's with a plus, but there's a minus in front of 5,000, so we're really subtracting probability that n is 2. Then the same for probability that n is 3. We had 4 of them, I'm sorry, the probability that n is 3, we had 2 of them, and we now have 3, so we need to subtract 1, and so on. And we do this for all numbers. Of course, now what we have is simply 5,000 times my expected value of n. That's the first sum, 5,000 times a big sum. And what we're subtracting is 5,000 times the sum of all probabilities with the exception of the probability that n is 0. So of course it's 1 minus a probability that n is 0, because all probabilities have to add up to 1. Okay, well, expected value of n is equal to the parameter c, which we calculated, so it's 5,000 times 0.5108256. And, you could just put in 5,000 times, in parentheses, minus natural logarithm of 0.6. And we subtract 5,000 times 1 minus the probability at n is 0, which is known to be 0.6, so it's 1 minus 0.6. And we calculate all this, and we get approximately 554, which is answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the